Last section of chapter 12, part A, we're going to look at how do we transform data to achieve linearity. And the first way I'm going to show you is what we call a power model. So when associations are nonlinear, what two approaches can we take to model those associations, to write an equation for it? Well, there's two ways to look at it, and there's only one way we're going to do it in AP Stats. You have to One way to handle it is to fit the curve, to find the equation that best fits that data. It could be quadratic, it could be exponential, it could be polynomial, it could be a lot of different things. But there's a lot of equations to choose from, right? That could take a lot of time, and that's another level of stats we're not going to get to. The other option is to straighten the association. I'm going to show you two ways we can straighten the association and then make it linear, basically. So this is the direction we're going to go in this section. What does a country's income per person, measured in gross domestic product per person, adjusted for purchasing power, say about the under 5 child mortality per 1,000 live births in that country? Here's the data for a random sample of 14 countries in 2009. Sketch a scatter plot and describe why it would not be appropriate to compute a least squares regression line. So if my income predicts the under 5 mortality rate, the income is explanatory and this is response. So if I do my scatter plot, it looks like this. And you can see it's curved. And that would be why a regression line doesn't work. So the least square regression line is not appropriate because the scatter plot shows a strong negative nonlinear association. So how can you linearize an association using the power model? And this is the general form that we use, right, for a linear regression line. Well, power model says this. You take the logarithm of your response variable and the logarithm of your explanatory variable. You can use the common log or you can use the natural log. Remember, common log has a base of 10, natural log has a base of e. Either way works. You just got to use the same type for x and y. All right? So power model, taking the logarithm of both variables to straighten the association. So use an appropriate logarithmic transformation to make the association linear. Sketch the resulting scatter plot and calculate the equation of the least square regression line, and then sketch the residual. All right, so lots to do in this one step. So in my calculator, here's what I've done. In list 1, I put the income data. List 2 is the mortality rate, because that's what they're saying is the response variable. List 3 is the logarithm of list 1, the data, income data. And list 4 is the logarithm of the mortality rates. All right, so I'm doing the logarithms in a separate list, and I'm keeping straight which one's response and which one is explanatory. So that's something you would write down. And then I'm going to go to stat calc and do the linear regression like we normally would, but now I'm going to differentiate. I'm going to say that the x list is list 3, the logarithm of list 1, and the y list is list 4, which is really the logarithms of the mortality rate. Now, that being said, what comes out is this equation, and I have to make sure that I write it as the logarithm of the mortality rate and the logarithm of the income. All right? Now, this should have a hat on it. It just didn't type out for this. But that is what the power model says. Okay, and this is the regression line it gave me. So if I then sketch a scatter plot of L3 versus L4, this is what my scatter plot looks like. So notice the curvature is gone. It's more of a straight line now. And then the residual plot, after I calculated my line, looks like this. It is a scattered residual plot, no leftover pattern. That seems like it's a good fit for this data. If I've taken the logarithm of both, that means it would be power model. And then lastly, it says use the logarithmic transformation. Predict the income per person for Turkey, who had a child mortality rate of 20.3. So child mortality rate is over here, right? And so it's asking us to predict. We're kind of having to rearrange our equation. So we use that equation we got, and we're just going to put in 20.3 for mortality rate. And we're algebraically going to solve this back for income. All right? So I'm going to first move that 5.43 over to the left side of my equation. Logarithm of 2.03 I can find in my calculator. I'm going to subtract 5.043. Alright, and I'm going to divide both sides by this coefficient of negative 0.989 to get the logarithm of the income by itself. Okay, so when I do all this in my calculator, I get 3.777. Now, to find x is in the logarithm. If you recall, the base is 10, so if I raise my base to whatever I get over here on the left, that will give me my x value. So 10 to the 3.777 power gives me 5,984.83. So this is the income per person for someone in Turkey.